So in this example problem, we're asked to determine what is the magnitude of the component force F shown in this figure. So this is uh, the component force F that's acting at a 45-degree angle with the y-axis. And then we're asked to also determine the magnitude of the resultant force, F of r, if the resultant force is directed along the positive y-axis. Okay? So what we have in this case is we have two forces. We have force F and we have a 200-pound force, which I'll call this as F2. So for these two forces, all right, we know that if we add those two forces together, we can get our unknown force F plus our force 2 will be equal to our resultant force. Okay. So what we can do here is we can say that we need to draw. What we're going to do is we're going to draw this triangle out geometrically in order to solve this equation to figure out what is the magnitude of F of r and what is the magnitude of force F. So we're going to start off by drawing our known force F2. So we know that F2 acts at a 30-degree angle with the positive x-axis. All right, we know it has a magnitude of 200 pounds. All right, we know that our resultant force, F of r, acts along the positive y-axis. So we're just going to draw a dotted line for now along the positive y-axis. All right, and we know that F of r will go somewhere along that dotted line. Where it ends, we don't know quite yet. So then the last part of the problem is we're going to draw the direction of our unknown force F. So our unknown force F, all right, we know will start at the end of F2 and it will end somewhere along the y-axis. All right, and we know that our force F acts at a 45-degree angle with the positive y-axis. Okay, so we know that if we drew out a triangle for force 2, we know that the other angle here would be 60 degrees. And we know that along a line, so along the y-axis here, we have a 60-degree angle and we have a 45-degree angle. So this angle, which I'll call alpha, we know that alpha would be equal to 180 degrees minus 45 degrees minus 60 degrees. All right, so that would be equal to 75 degrees. Right, so we know alpha is equal to 75 degrees. We know that the other angle of the triangle here, it would be equal to that's going to be equal to 60 degrees, and then that gives us the angle, called the angle beta. We know would be equal to 180 degrees minus alpha, which is 75 degrees minus 60 degrees. So that's 135 degrees, 180 degrees minus 135 degrees, which would be equal to 45 degrees for beta. Okay, so what we end up having now is we have our triangle all drawn out. We know all the three interior angles of the triangle. We just don't know the two sides of the triangle, the force F and our resultant force Fr. Okay, so what we can do is we can use the law of sines to help solve for our unknown sides. So we can say, you can say the sine of beta, which is equal to 45 degrees, over the known magnitude of 200 pounds, is going to be equal to the sine of alpha, which is in this case is equal to 75 degrees, divided by our resultant, the magnitude of our resultant force, Fr. And we also know that the sine of 60 degrees over the magnitude of our unknown force, F, would also be equal to the sine of 45 degrees over 200 pounds. So we can rearrange these equations to solve for Fr and F. So if we look at just the two terms in this equation, the two leftmost terms, we can solve for Fr using those two terms. So we can say Fr would be equal to 200 pounds times the sine of 75 degrees divided by the sine of 45 degrees. So that's going to be equal to 200 pounds times the sine of 75 degrees is 0.96593, and then the sine of 45 degrees is radical 2 over 2. So that's going to give us it's going to be equal to 273 pounds. All right, and then if we looked at our leftmost term and the rightmost term, we can solve for our unknown force F, or the magnitude of our unknown force F. So that would be equal to 200 pounds times the sine of 60 degrees divided by the sine of 45 degrees. So that would be equal to 200 pounds times radical 3 over 2 divided by radical 2 over 2. Alright, so that would just be equal to the radical 3 over radical 2, which is basically 200 times the radical 3 over radical 2, which is just going to be equal to approximately 245 pounds. Okay. So just to recap what we did in this problem here, we first determined our algebraic equation that we needed to solve for. We determined that our two unknowns were the magnitude of our force F and the magnitude of our resultant force. We knew the directions of those two, so we drew out our triangle that represents our algebraic equation. Using geometry, we were able to solve for all the interior angles of our triangle, and then using the law, once we had all the interior angles and we knew that force 2 had a length or a magnitude of 200 pounds, we could use the law of sines to solve for our two unknowns, Fr and F. And then we just did some algebra and we were able to solve for the magnitudes. All right, so that concludes how you can use the law of sines to solve for the magnitude of our resultant force with a given magnitude and direction of the other two forces.